Questions 21 through 25 on the 2021 Grade 9 Pascal Math Contest. 3 cubes have edges length 3, 12, and x centimeters. The average volume of the 3 cubes is 700 centimeters cubed. The value of x rounded to the nearest integer is volume 1 plus volume 2 plus volume 3, all divided by 3, they're saying is 700 centimeters cubed. The average of the 3 volumes. Well, the volume of a cube is given by the formula s to the power of 3, where s is the length of the edge. In our case, v1 would therefore be 3 to the power of 3, since that has an edge length of 3. The second volume would be 12 to the power of 3. And then the third one would be x to the power of 3. That's all over 3, and that equals 700. Let's do the math now. This is 27. 12 to the power of 3 is 1728, and then x to the power of 3, cross multiply and you get 2100. And then x to the power of 3, 2100 minus 27 plus 1725 is 1755, and therefore x to the power of 3 would be 345. And then take the cube root of both sides, and when you do, you get 7.01 approximately. Therefore, the nearest integer is, of course, 7. And therefore, number 21, the answer is E. ASME has 4 blocks, each in the shape of a rectangular prism and each with dimensions 2 by 3 by 6. She carefully stacks these 4 blocks on a flat surface table to form a tower that is 4 blocks high. The number of possible heights for this tower is. You have a rectangular prism, and we are told that it's a 2 by 3 by 6. So some sort of a shape like this. And then the way you stack it, we have a few ways to stack it, right? You have, for example, one way would be to put this 2 side as the height, like this, and then just put them up like that, one on top of one another. So it'd be 2, 2, 2, 2. And that, of course, would give you a height of 8. So 8 is possible with 2, 2, 2, 2, and I believe that is the minimum. Can't go anything smaller than 8. The maximum would be if you put the 6 side, this side, as the height, and then just stack them up one on top of the other like that. That would give you a height, obviously, of 6, 6, 6, and 6, which is 24. And that is obviously the maximum. So my question is, are all the integer values between 8 and 24 possible? Well, let's see. What we have to do is sort of go through them all and see. Well, let's see. I think I'm going to go backward because I immediately can tell that 23 and 22 are not possible. For example, if I have just 3 6s, because 4 6s is the maximum. If I have 3 6s, and then the last number can be 3 or a 2. Those are the only way. But 6, 6, and 3, 6, 6, 6, and 3 is 21. So that means that 23 and 22 are not even possible. Not possible, not possible. This is possible with 6, 6, 6, and 3. And then 6, 6, 6, and 2 would make me arrive at 20. Okay, so let's just keep going like this. Now, if I have only 2 6s, then that'd be 12. If I add 2 3s, it would bring me up to 18. 6, 6, 3, and 3. So there's no way of getting 19 either when you fiddle around with this. Okay, so let's just keep going here. 6, 6, 2, and 3, that would give me 17. 6, 6, 2, and 2, that would give me 16. 15 I think I can get with just 1 6 and then 3, 3, 3, and 3. 14, 6, 3, 3, and 2. 13, 6, 2, 2, 3, that would give me 13. 12 I can get with all the blocks being 3 as the height. 11, let's see, 3, 3, 3, and 2. 10, 3, 3, 2, 2, that would do it. And then 9, 2 3s, or just 1 3, and then 3 of those 2's. That would give me a 9. Yeah, so it's all there. So when you count the ones that I'm able to do from 8 to 24, but not including the 19, 22, and 23, that's a total of 14. So the answer to this question is B. Rectangle WXYZ has WX equals 4 and WZ equals 3 and ZV equals 3. The rectangle is curled without overlapping into a cylinder so that sides WZ and XY touch each other. In other words, W touches X and Z touches Y. The shortest distance from V to W through the inside of the cylinder can be written in the form the square root of A plus B pi squared over C pi squared. The smallest possible value of A plus B plus C is. Well, let's draw this and see what happens. When it is curled up, it will become a cylinder, as they state. And let's start labeling this now. So let's just say this is the point where W and X meet. And then, of course, down here would be the point that Z and Y meet right there. Now, I have to think about, where do I put V? Is V here? Is it here? Is it here? Well, just go back to the original diagram. This is 3, this is 4, and they told me that Z to V is 3. So that obviously means that V to Y is 1. So V to Y is basically a quarter of the full distance from Z to Y. So that means it must be here. That is where V is. So it's looking like an oval, so I'm going to just draw that circle. That base, if you're to look at it from a bird's eye view or from below, it would be a circle, obviously. And this would be where Z is, and this would be where V is. It's exactly a quarter of the distance. So if you're going to draw a center and draw lines from the center to the ends V and Z, it would basically represent a quarter circle. And therefore this is obviously a right angle. Okay, so that's pretty decent. So let's do the exact same labeling in here. We're going to draw the circle, and then we're going to draw those. I drew it as a bird's eye view because it's a little bit clearer over here than it is up there. Okay, we got that. Now we have to start talking about a different distance. That is the distance from W to V. That is what they want. Okay, well, the shortest distance between W to V is obviously a straight line like that. And then I see a Pythagorean relationship. If I draw a line from there to there, this is a right angle right there. So if I can get the distance from Z to V, I think I can figure this out. Well, Z to V right now, I don't know what it is, so I'll just label it as X. This distance, however, I do know, that is 3. So that I can label as 3. So immediately I see that WV squared is equal to 3 squared plus X squared. So if I can get the value of X, I can solve this. All right, so let's look at that other diagram to figure out in a more clear way the value for X. The green lines represent the radius, right? So I'll just call that radius R and R. Well, the distance from here to here is 4. So that means the entire distance from there to there, the circumference, is 4. That's basically how that cylinder was made, by curling up Z to Y. So this whole distance is 4. So circumference of the circle is equal to 4. And we know that circumference is equal to pi times the radius, 2 times the radius, and that's equal to 4. Circumference is equal to pi times 2 times the radius. So solving, we get pi r is equal to 2, and therefore r is equal to 2 over pi. All right, now I can use this diagram to figure out x. X squared is equal to r squared plus r squared using Pythagoras. X squared is equal to 2r squared. X squared is equal to 2, r is 2 over pi squared. So that would be 8 over pi squared. All right, I'm ready to figure out WV. WV squared is 9 plus x squared. Well, x squared is 8 over pi squared. And then get a common denominator, and you get 9 pi squared plus 8 over pi squared. And therefore, finally, WV will be the square root of that. So 8 plus 9 pi squared over pi squared. Compared to that form, which is a plus b pi squared over c pi squared square root, it looks to me that a is 8, b is 9, and c is 1. And therefore, a plus b plus c would be 8 plus 9 plus 1. And that is, of course, 18. So number 23, the answer is C. Suppose that k greater than or equal to 2 is a positive integer. An in-shuffle is performed on a list with 2k items to produce a new list of 2k items in the following way. The first k items from the original are placed in the odd positions of the new list in the same order as they appeared in the original list. The remaining k items from the original are placed in the even positions of the new list in the same order as they appeared in the original list. For example, an in-shuffle performed on the list PQRSTU gives the new list PSQTRU. A second in-shuffle now gives the list PTSRQU. Ping has a list of 66 integers from 1 to 66 arranged in increasing order. He performs 1,000 in-shuffles on this list, recording the new list each time. And how many of these 1,001 lists is the number 47 in the 24th position? Well, let's first examine this and explain it. So PQRSTU, we're going to do an in-shuffle. So there's 6 spots, right? Okay, let's just go right by the definition. This is 2k, and in this case, I guess 2k is equal to 6, so k is equal to 3. The first k items, so in this case the first 3 items, are placed in the odd positions of the new list. Okay, so these first 3 are placed in the odd positions. The odd positions, let's label all the positions first. The odd positions would be 1, 3, 5, and so on. So P goes here, Q goes here, R goes here. Then the remaining k items from the original are placed into the even positions of the new list in the same order. Well, the remaining are these guys, STU. So STU go into the even spot. So S, T, and U. And if they even gave you that, they told you. I just wanted to illustrate it. And then if you do it again, you would eventually get this one. Okay, so now let's talk about the question. The question is saying that you're going to do the same sort of story, but this time for numbers 1, 2, 3, all the way to 66, 65. So again, I want to break it into 2 halves, right? The first half and the second half. The first half obviously goes up to 33, and then we start at 34, and then we go to the second half. 2k in this case is 66, and k therefore is 33. All right, so let's start with that. So I will explain it for the first few, and then basically we're trying to get a pattern here because we have to eventually get the number 47 to be in the 24th position. Okay, so let's start. So at the very beginning, the list looks like this, right? It's just 1 through 66. So that is list number 1. Okay, where is number 47 in this list number 1? Well, obviously it's somewhere in here, right? Dot, 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 somewhere in there. And what position is it in? Well, it's in position 47. So the position that it's in, I'll put it underneath it, and I'll put it in a different color. 47th position, obviously, nothing's been changed. But now we do our first kind of in-shuffle. The first in-shuffle would say that you would take the first k, which in this case is 33, and put them into the odd positions. So that's what you're going to do for the first 33. So I'll just put it down there. The ones from 33 to 1, you put into the odd positions. The ones from 34 to 66, you put in the even positions. So I don't really care so much about these guys. I'm just concerned about where's the 47. That's over here. So those numbers are going to be put into the even positions. Okay? So where does the 47 go? Well, count. Where is 47 in here? It's 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. It is the 14th number in this half. So it would go into the 14th even spot. 14th even spot. And what is the 14th even spot? Well, it's 14 times 2, which is 28. So that means the number 47 would now be in the 28th position. Okay, hope that makes sense. Let's move along. Now, the 47 is now in the 28th position. It is somewhere in that first half. Now that means it's going to go into the odd positions. It's in the first half, so it would go into the 28th odd spot. What is the 28th odd spot? Well, 28 times 2 minus 1 this time. So 28 times 2 minus 1 is 55. And therefore, the number 47 is now in slot 55. And then you just keep doing this. So I'll just keep doing it. I think if I talk you through it, that's perfectly fine. Now we're up to, I guess, round number 4. Now we're in the 55 spot. We're somewhere in this kind of area. Number 55 just in this list is what number? Well, you got to start from 34 and count. 34, 35, 36, and so on. When you do, it is the 22nd number. The 22nd number, and because it's on this side, it would go into an even slot. The 22nd even spot or slot, whatever you want to call it. Well, that's easy. That's 22 times 2, so that's number 44. The 44th spot is where the 47 now lies. So we got it in spot 44. Eventually, we have to somehow get it into spot number 24. So that's our goal. So eventually that will happen. How long this will take, that I don't know. Let's keep going. Now, next round, it's in odd position number 44. So again, we've got to count. Position 44, if you count from 34, is the 11th spot. And because it's on that side, it will go into an even spot. So the 11th even spot is where it now goes. And that is 11 times 2, which is the 22nd spot. So now 47 is sitting in spot number 22. Okay, let's keep going. Number 6, it's now in 22, so that's on this side. So that means we have the 22nd. Interesting again. Oh, okay. The 22nd, but this time it is the 22nd odd spot. So that's the difference. The 22nd odd spot would be 22 times 2 minus 1, which is 43. So now the number 47 is sitting in the 43rd position. Okay, now we have to do 43. So we're again back into here somewhere. So we have to say, where is it? If it's 43, it's 34, 35, and so on, right? It's the 10th number in this list. If you start with 34, number 43. So it's the 10th number, but because it's on this side, it's going into even spots. So the 10th even spot is where it goes now. And even spots are pretty straightforward. There's just 10 times 2, so which is the 20th spot. So now our 47 is in the 20th position. All right, let's just keep going. Now we've got the 20th spot, but because it's in the first 33, it will go into an odd spot. And therefore that's 20 times 2 minus 1, which is 39. And therefore 47 divided by 39. Well, it's not divided, sorry. These are not fractions. The 47, number 47 is in the 39th position. That's what that denotes. All right. Let's keep going here. Number 9. 39. Well, 39 is the sixth number in that half. So it would be now the sixth odd spot. The sixth odd spot. And that would be the sixth even spot. Because 39 is in this category here. Okay, so the sixth even spot, that's just 6 times 2, which is 12. So now the number 47 is in the 12th position. Okay. Now, the 12th position, that would be basically the 12th odd spot. And that would be 12 times 2 minus 1, which is position number 23. So now, number 47 is in position number 23. Keep going. Round number 11. Now we got the 23rd odd spot. And that would be 23 times 2 minus 1, which is 45. So now the number 47 is in position 45. Okay. Number 12th round, 45. That is what the 12th number in the second half in these guys. So it would be the 12th even spot. And that is 12 times 2, which is 24. Finally, we got it. We are now in the 24th position. That is what they want. They want the number 47 to be in the 24th position. So we have arrived, and it came on the 12th. Let's just do one more to see what happens. If we do the 13th, it would be the 24th odd spot. And that is 24 times 2 minus 1, which is 47. So the number 47 would be this time in position 47. So basically right back where we started. If you remember, we started there, we get right back where we started. And so if we continue, we'd basically continue down the same list. So it looks to me that this list repeats itself every 12. As you can see, once you get to 12, you get right. It repeats itself every 12 because once you get to 13, you get right back to where you started. Okay. So our total number is 1001. So all I have to do is just divide 1001 by 12 to see how many times I've got to go through that pattern. And when you do, the integer value is 83. That's what this symbol means. And that's the answer. So it took a little bit of work, a little bit of patience. Don't mix up the odd and even. That I think I did that once, but I corrected my mistake. Okay, so number 24, the answer is C. Jan writes down the first n consecutive positive integers, 1, 2, 3, 4, all the way to n minus 1 and n. He removes 4 different integers, p, q, r, s, from the list. At least 3 of p, q, r, s are consecutive, and 100 is less than p, less than q, less than r, less than s. The average of the integers remaining in the list is 89.5625. The number of possible values of s is p, q, r, and s. Those are the 4 numbers. Now, they're saying that at least 3 are consecutive. Okay, so that means either 3 are consecutive or 4 are consecutive. If 4 are consecutive, this would be x, x plus 1, x plus 2, and x plus 3, right? And then the sum, which I can just denote as, I guess, s. Don't get confused with that s. I'll just call it s, large S for sum. It looks to me like 4x plus 6. That's if all 4 are consecutive. If only 3 are consecutive, then let's say that P, Q, and R are consecutive, like that. And then S is some S, we don't know. The sum here looks to me like 3x plus 3 plus S. How about if the 3 consecutive were P, R, and S? So it'd be x, x plus 1, and x plus 2, and this is Q. Therefore, this is going to be 3x plus 3 plus Q. That's sum. And then similarly, if you made the 3 consecutive P, Q, and S, it would be x, x plus 1, and x plus 2, and this is R. So it would be 3x plus 3 plus R, the sum. And then finally, if the consecutives were Q, R, and S, it would be like that, where this is just P. So then again, the sum would be 3x plus 3 plus P. Okay, so these are the possible ways of doing it. Now, at this point, I have to do a little bit of an approximation because they don't actually give me the value for n. They just say, okay, it's some n. So, but I have to sort of know at least ballpark estimate, where is n? Is it 105? Is it 200? 500? Right? I have to get some sort of an approximation. Okay. Well, they told me that the average of the remaining integers is that. So that's very helpful because you took n and then you subtracted 4 integers. You removed 4. So the average basically could be thought of as follows. I take n and I remove 4 and I get the average, right? Okay. But let's just say I didn't remove those 4 numbers. I just take the full average of all the numbers, and let's just say it's sufficiently close to that. Therefore, I can get an approximate value of what n could be, ballpark estimate. Okay, so let's do that. I've got to first add up all my numbers all the way till n, and then to get the average, I have to divide by n, and I'm saying that that is approximately equal to 89.56, right? Okay, so what do we get here? Well, that, you know this, right? The formula for that is n times n plus 1 over 2. And then we divide by that n, and this is, the full number is 89.5625. Okay, so n times n plus 1 over 2 times 1 over n is equal to this 89.5625. It looks to me like that n cancels, so I just have n plus 1 over 2 is 89.5625. And then I can just easily sort of work this out. This looks like n plus 1 is equal to 179.125, and therefore n is equal to 178.125. So that is very helpful. It gives me some sort of an estimate as to approximately what n could be. It may be 178, 179, maybe it's 177, but somewhere around there. So n is approximately 178 and somewhere in that vicinity. Okay, so that's very helpful. So now let's move forward. Okay, let's just jump right in. Let's say we take the full sum, we subtract those 4 numbers, and then we figure out the average. So I'm going to start off with, well, we might as well just start off with n equals 178. I'm not sure that it's 178, but let's see what happens. So first, to get the average, we would take the sum of all the numbers, which is n times n plus 1 divided by 2. All the numbers from 1 to n. This is the sum. And then, since we're setting n equal to 178, I can just put in 178. Let's do that. So 178 times 179 over 2. And then from that, I have to subtract those 4 numbers. So first, let's do it for this scenario here. Okay, so I've got to subtract 4x plus 6. And then I have to divide this time, not by n, but n minus 4, because remember, I removed 4 numbers. So n is 178, so I have to divide by 174. And that, they told me, is 89.5625. Okay, so let's do this math. This is 15931 minus 4x minus 6. and that gives me 15583.875. Okay. Well, that's a problem. That's a problem because when I solve all of this, I'm not going to get an integer. Because I've got this decimal here. Even if I divide through by 4, it's not going to be an integer. X has to be an integer. They told me specifically that these are all integers. Okay, so that basically means that this scenario is no good. Put a line through it. Or just put a little x beside it like that. Or just put a bracket around it. Whichever way you want to denote it. So that means I've got to use one of these 4 scenarios here. Okay, so let's do that. Let's talk about these though before I get into one by one. Are these possible? That's very important. This one is definitely possible according to the criteria. However, the next one, notice, is not possible because how can you do that if they're all integers? X here, x plus 1 here. Q, if it's an integer, there's nowhere for it to go. If this, for example, was 11, this would have to be 12. Q, there is no integer between 11 or 12, right? So this one is not possible. So put a bracket around there. For the same reasoning, the next one is not possible. If this was, say, 15 and then x plus 2 was 16, there's no integer that's between 15 and 16, right? So that one is not possible either. But the last one is. The last one is definitely possible. You can put some number and then you can put 3 consecutive numbers. So we are just going to go with this and try to solve the question. But before we even get into that, I've got to solve this decimal problem. I can't have a decimal if I have any hope of getting integer values. So that means that when I do this cross multiplication, this number here times this, it's got to end up to be a whole number. So you take this number and start multiplying by numbers to see what does it need to be multiplied by to give a whole number. And the smallest number that you need to multiply this by, if you do this in your calculator, is 16. 16 is the smallest number. So whatever I put here has to be some multiple of 16. And that is in my opinion, the key to the question. Because otherwise it takes forever. Okay, so what can that be? A multiple of 16 that is hovering around this 174 value is 176. So 176 is what I'm going to put there. So that basically means that n would be 180, right? Because what I put in here is n minus 4, remember. So now, let's try it again. Again, n is now my 180, so 180 times 181. Minus, let's just do the same scenario, 4x plus 6. Let's keep it exactly the same for comparison purposes. 89.5625. Now when I do the cross multiplication, it's great because it becomes an integer. 176 times 89.5625 as planned is an integer. It's 15763. And it gives me an integer on that side. On this side, we will have, forgot the 2 there, 16290 minus 4x minus 6. Okay, that's pretty good. So if I'm going to solve for x, bring everything over, and we're going to get 4x plus 6 is equal to, when I make that subtraction, it's 527, and therefore 4x is 521. And then x would be 130.25. Oh, that's a problem because x represents p and p has to be an integer. Okay, so that's no good. Well, not a problem. That just means I have to concentrate on this scenario and this scenario. Okay, so let's do that. Let's concentrate on those two, but with my n equals 180. So we have already shown that we can only deal with these two scenarios. So let's start. For the first one, it would be, since n is 180, 180 times 181 divided by 2 minus this time 3x minus 3 minus s, and then divided by n minus 4, which is 176. And that is equal to our 89.5625. Okay, so let's do this math now. This is going to be 16290 minus 3x minus 3 minus s, and that is an integer as planned, 15763. Solving for s, we get 524 is equal to 3x plus s. Okay, we can't quite yet solve for s. We have two variables. So at this point, we have to make a table. And let's make a table and see what we get. Basically, it boils down to finding integer solutions for x and s. So let's find integer solutions if we can. And then before we do, we've got to set some parameters, right? Our parameters are, let's see, well, x has got to be greater than 100, according to the question, and it's got to be less than 180, because you can't go past 180. And it looks like s probably has the same sort of criteria, at least for now. And s also has to be greater than x plus 2, because remember, these have this sort of inequality relationship. Okay, that's pretty good for now. So now let's make some numbers according to that. Well, if I start with the smallest possible, which is 101, I get 221, and that falls apart immediately because s has to be less than 180. So I keep going down, and eventually I get to 114. That gives me 182. That's still not in my range, but the very next one, 179, that falls in that range when x is 115. And then I keep going, and then eventually I get to 130 for x, gives me 134. And then at that point, I start to fail this one. Everything in here, this range is fine. But then my next one, 131, gives me 131 for s. And that does not satisfy that condition. So then anything onward is not going to work. So the only ones that work are these ones right here. So 115 and so on until 130 for x, and then 179 and so on until 134 for s. And that is 16 values. Okay, so you can say, okay, great, 16, I'm done, right? Well, let's look at the answer choices. There is no 16. They're all greater than 16. Okay, so that makes me think that I've got to add a few more. So somehow I've got to come up with a few more. All right, let's see if I can. So first, let's just list all of these 16 just to have a nice comparison for us. So the 16 that we identified were from 179 all the way down to 134. So these 16. All right, so now we've done that. Now we have to do this one right here. So same story, 180 times 181. Remember, n is 180. And we're finding the sum, and then we're subtracting this time p plus 3x plus 3. Okay, and then of course we have to divide by the numbers, which is 176, and that is equal to that 89.5625. So the numbers are very similar, almost identical here. It would be minus p minus 3x minus 3, and that would be if you cross multiply the same number, which is 15763. And then that would be the same kind of story, I believe. 524 is equal to 3x plus p. So now again, let's make a table. And before we start filling out the table, let's talk about our parameters. The parameters are very similar, but the big one here is that p has to be less than x, as you can see right here. P has to be less than x. The same kind of story that x is between 100 probably and 180, and p, same thing, at least for now. But p P has to be less than X. Okay, so let's go. It's going to be pretty much the same numbers as we have over here, but this time the numbers are not for P and X and S, they're for X and P. All right, so here we go. When we start at 101 for X, right, or for P rather, you get 141. Okay, the parameters are all satisfied here, so this is legitimate. So I'm keeping that one. And then in a very similar way, let's just keep going here. 104 would give me 140, and I'm really looking for integer values. So 107 gives me 139, and so on. And you just keep making this list. So 110 would give me 138. 113 would give me 137. 116, 136. 119 would give me 135, 122, 134, 125 would give me 133, 128 give me 132, and then 131 would give me 131. Oh, okay, now this fails this inequality. So at this point, I can only therefore look at these guys. Now, remember, I really want S. This table has P and X, that's fine, but I want S. And what is S over here? S is X plus 2 this time, right? So S is equal to X plus 2. Okay, so now let's figure out. Let's add another column to this table. And let's put S there and see what we get. So S is X plus 2, right? Okay, so this is going to be 143, 142, 141, 140, 139, 138, 137, 136, 135, and 134. Okay, now there's some doubles here, so I can't just add what I got here to this. I got 16 over here, if you recall, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I can't just add those 10 and say, oh, it's 26, because there's some doubles here. The doubles are, let's see here, 143 is a double, so I can't count that. 140 is a double. 137 is a double, and 134 is a double. So the only new ones that I got were 1, 2, 3, 4, 5, 6. So I got 6 new ones. So I take this 16 and add to these 6 new ones, and when I do, 16 plus 6 is 22. And that is the total number of values I can get for S. And therefore, this interesting question, number 25, the answer is E.